All right, so that was about the graphs, and a bit extension in that is in your exams they also ask you a bit more. So y equals sine theta. Y equals sine theta, right? So for example, over where did I drew the sine curve? Over here, I drew the sine curve telling me that this is sine theta and this is theta. Y equals sine theta is just saying instead of sine theta, you just write y, right? So, so this is already done, but what they also ask you is y equals some modifications to it. So y equals a sine b theta plus c. All right. So, 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 if I tell you that, if I ask you what does y equals 2 sine theta, what does the graph of y equals 2 sine theta looks like, right? So I know that sine theta looks a bit like this. Let me draw it a bit shorter. I know that sine theta looks like this, right? So if I'm multiplying every output that I'm getting in multiplied by 2, so what's really happening is I'm exaggerating the y value by a factor of 2. So if at this point there was a certain y value, this would be multiplied by 2 to get to here, right? And over here it was 1, it will go to 2, right? So the maximum value would be 2, and the same would be repeated for every value. Here the distance or the displacement, I should say, it was -1, and when you stretch it by a factor of 2, it will be at -2. And, and 0, of course, goes to 0 because, well, 0 multiplied by 2 is 0, right? So what you realize is that multiplying by 2 has this effect of just increasing the amplitude, right? Just to draw it more neatly because these graphs are terrible. What A in A sine okay, if I just write A sine theta, what A really tells you, it tells you how much deviation there is from the mean position. So if A is just one, the deviation from this line is zero. If I take two, this should be two. So the extreme values, which is this point and this point, will be more exaggerated. It will multiplied by two. It will look something like this, right? So this is the effect of A, right? And if I tell you the same about a cos theta, right? If I tell you what is 2 cos theta, then you'd apply the same principle that, this is cos theta, this was not cos theta, this is still not cos theta. Oh, okay. So let's say this is cos theta, right? So two multiplying that by 2 would have the effect of exaggerating the values by a factor of 2. So this would be 2 sine theta, right? And of course, if multiplying by 2 is giving exaggerated value, multiplying by half will give you an undermined value, right? Multiplying by half would mean that the deviation from the mean line is half. So if this is 1, this is 2, this would be half, right? And this would look something like this, right? If you look at your notes, these are drawn much better, right? And of course, this continues to a 10x. So if I ask you what is -2 times 10x, well, the significance of negative is just reflecting it in the line that is parallel to the x-axis. So previously, tan theta looked like this for 0 to 90. Now it will look like this. Now it will look like this. Okay, it will just be a reflection, and you multiply it by 2, so it will look even steeper, right? And of course, you repeat that for every value, and the end result that you will get will be this, right? Compared to this would be tan theta. This would be negative tan theta, right? And this is our original graph of tan theta, right? a lot of graphs. They're drawn much better in your notes. Right, moving on. What if I say y equals sine theta plus a 1, right? So this is my normal sine curve, right? And what the plus one is really doing, it's taking every point and shifting it. So if I take this point, at this point the y value is 1, what it's doing is shifting every point 1 units above, right? This point will be shifted 1 units above, this point will be shifted 1 units above, this point will be shifted 1 units above. So every point on this curve is being shifted 1 point above. So the whole curve is just being shifted 1 point above. So what really ends up being is that if this is 1, this becomes my mean value, and from this we deviate 1 above, we deviate 1 down, we deviate 1 above, we deviate 1 down, and we get the graph of sine plus 1 theta, right? All I did was I shifted every point on the curve 1 units above, so this becomes 2, this is 0, right? And you get your sine theta plus c. So if I have anything, right, if there's some value, there's some value, the significance of this outer plus value is just shifting up or down, right? If it was a negative value, it would shift down. To give you an example, let's take cos quickly. So cos theta minus 2 would look something like this, right? So instead of starting at 1, it will now start at 1 minus 2, which is negative 1, right? So negative 2. And then when when it would have been negative 1, instead of negative 1, it would be negative 1, negative 2. So with that is negative 3. So my cos graph looks like this, right? And of course, the same for tan theta. And to also speed run the other part, sine, let's say I ask you what is sine of 2 theta. Well, this has an effect of squishing the scale in the x-axis, right? And the reason is that the values of theta that you're putting are being exaggerated by a factor of 2. So normally in your sine curve looks like this, right? So at the value of 90, let's say, your sine gives a value 1, all right? But if I take the graph of sine 2 theta, what would happen is that the theta would first multiply by 2, it would give me sine 180, right? So if I have to draw the curve of sine 2 theta, at 90 degrees, it will give me what sine would give at 180 degrees, right? So at 180, sine 2 theta gives me 0, so I put the 0 over here. And so essentially what's being happened is that this original value is being shifted over here, right? Everything is being squeezed by a factor of 2, if you want to think of it that way, right? So this 2 theta would also increase the frequency if you want to think of it that way. So it will look like this, right? And oops, this will not look like this, it will look like this, right? What you will also realize is that previously a sine theta was completing a whole curve in 360 degrees, right? And now it is completing one in 180 degrees, right? So for any sine b theta, right? The significance of b is actually that 360 over b would give you the degrees in which it's completing a one whole cycle. And by one whole cycle, I just mean that it starts from this value and returns back to this value. What it would sort of mean on a unit circle is that you had the effect of rotating a full round. All right. And this is all for now. This is all for sketching and getting started with Trig. And what would be left would be would actually be identities and stuff, right? So now you're mostly done with the conceptual part. What's really left is more of the algebra and solving trigonometry with in quadratic functions and stuff like that, right? So more on that later. Bye.